Welcome to You Got Hope Chemistry. I'm Hope, and you're about to learn some chemistry. So today's lesson is going to be a little bit different than our previous lessons. It's really going to be a focus on reviewing everything we've learned about qualitative analysis, as well as writing, net reactions. And it's lab-based because we haven't had the chance to be in the lab due to our current circumstances. So I'm going to read through this with you, and you're going to do a similar task when we are done. So let me start with this theoretical lab that we're going to do. So it says a student was given a sample containing an unknown number of ions. The teacher explained that the solution could possibly contain lithium ion, calcium ion, lead 2, copper 2, or cobalt 2. The student was told to identify the ions present using selective precipitation, solution color, and flame tests. The selective precipitation was carried out by adding a series of solution to the sample in specific series. Okay, so what we need to remember here is these are the possible ions. It doesn't mean that we have all of these ions present, and it's really important that we have our solubility table as well as our precipitation table, our solution, and flame color table. All right, so the first set of observations says the original sample color was red. So let's go through and identify out of these ions which ones have a solution color, and if so, are they red? So I'm looking at my solution color table. Lithium is not there. Calcium is not there. Lead 2 is not there. Copper is. So the copper is, copper 2, it says it's blue. And then it has cobalt 2 as well, and it says that cobalt 2 is red. So my original sample color is red, so I know that the cobalt 2 plus ion was there, so this has been confirmed that we do have it. Now the other thing I'm going to take in consideration is, I'm not going to quite commit to it 100% at this time, but I don't think there's any copper 2 here. If there was copper 2 and blue and red mixed together, that would make the color purple. The solution color isn't purple, it's red. So I'm pretty sure there's no copper 2, but we'll double check that as we go along to make sure that I'm not incorrect. All right. Now it looks like we're going to do a series of selective precipitations using a bunch of different acids. So before I go through each one, I'm just going to look at what we're adding. So hydrochloric acid really is H plus and Cl minus. The addition of sulfuric acid, that's really H plus and SO4 2 minus, because those are the ions that make them up. And then the last one, hydrosulfuric acid, which is H plus and S2 minus, because hydrochloric acid is HCl, this is H2SO4, and this is H2S. So all acids have hydrogen ions in them, and then they have an anion. Now, because this question is dealing only with cations, so the lithium, calcium, lead, copper, cobalt, I don't care about the hydrogen ion. It doesn't matter to me, because those positive ions are only going to form a precipitate with something which has a positive charge. So let's look at the first one here. It says, a white precipitate forms and is filtered over the filter paper, and the solid is kept. So I have a white precipitate forming. So immediately what I'm going to do is I'm going to go to my solubility table, and I'm going to look up what is insoluble with chloride. And so the things that are insoluble with chloride are copper 1, silver 1, mercury, lead 2, and Tl plus. Now, looking at these, I mean, I don't have copper 1, so this isn't going to be the precipitate. I don't have silver in my list, so that can't be it. I don't have mercury in my list. That can't be it. I definitely have lead 2. There's lead 2. And I don't have Tl+. So it must have formed a precipitate with lead 2. So this must be PbCl2 solid. Okay. All right. This has now been removed from the solution. So I'm going to just say removed. We got to ignore that now because we don't have it anymore. All right, next step. The addition of sulfuric acid means we have sulfate ion. So what I'm going to do is I'm going to look up sulfate and I'm going to write down all of the ions it's insoluble with. So sulfate is insoluble with calcium 2+, strontium 2+, barium 2+, silver plus, mercury, lead 2+, as well as Ra2+. Now, what I have to keep in consideration, and this is really, really important, is I've already got rid of the lead. So I'm going to cross that out because I've already removed it in the previous step. So what I'm going to do is I'm going to continue to look through what I have and see if anything matches up. All right, well, look at this. I have calcium here, and I have calcium here, so that's probably what I removed. I'm going to say removed, and we're just going to double check, okay? All right, do we have strontium? No. Do we have barium? No. Do we have silver? No. Do we have mercury? No. Do we have radium? I sure hope not. So none of those are there. So I'm just going to cross them out because they're not even possibilities. They weren't even part of this. So this must have made calcium sulfate solid because the calcium would have formed a precipitate with the sulfate. Let's look at the next one. Step 3, the addition of hydrosulfuric acid. So now S2- is not part of our data book anymore. So I'm going to have to tell you what it is insoluble with. Okay, S2- is only soluble with group 1 cations and group 2 cations, as well as NH4+. So I forgot to change this one, but that's not too bad. That's what S2- is soluble with. And so we're going to see what else it could react with. Okay, so first thing, it wouldn't have formed a precipitate with lithium because lithium is a group 1 cation and sulfide is soluble with it. This is already removed. This is already removed. I know this is not there because the solution wasn't blue or purple with the two colors mixed. And so all I have left is cobalt. Now there is a bit of a hint here as well. It says it forms a reddish pink precipitate. And if this is a red ion, it'll tend to form a precipitate of a similar color. So I know that this must have removed the cobalt 2+ aqueous for two reasons. It's making a reddish pink precipitate, and this is normally red in color. There is no copper 2 present because the solution wasn't blue. And lithium is soluble with sulfide, so that can't be it. So what I must have formed was COS solid in this step, step number 3. Okay. So now I have this removed, not just identified, but actually removed from the solution. And then it says, after dipping a flint in a solution, it gave us a bright red flame color. So going to my flame test color table, I noticed that there are two reds. One of them is lithium, which is Li+. And then there's a scarlet red for strontium, but strontium isn't in my list, which means it wasn't strontium causing that flame color. So the answer to this would be lithium. Now lithium wasn't removed by precipitation, but it was present due to the flame color. All right, So now we're just going to answer a series of questions on this. So it says, what ions were present in the original solutions based on the results? Well, we know we have cobalt 2 plus because the solution color was red and it precipitated out in the end. We precipitated out the Pb2 plus with chloride. We precipitated out the calcium with sulfate. We did a flame test color and we know that there's lithium present. So we have everything but the copper 2. Then it says, what ion was confirmed in the solution based on the results in step 1? So going back to step 1, we added hydrochloric acid, it removed the lead, so we know it was Pb2 plus. What would the students see if they took the solid collected after step 1 and placed it into a Bunsen burner flame? So what we would do is we would look up lead on our flame test color list because that's what we have. So we bring this down. And if I look up lead, it gives actually a blue-white flame color. So remember, flame color tests can be done with dipping sticks into solution, having it soak up the solution, and then putting it into a flame. But also you can actually take solid, put it right into the flame, and you'll also get a flame color. Okay. And then it says what ions or ions were not in solution. Well, we know the copper 2 plus was not in solution because it wasn't blue in color. And when I say it wasn't blue in color, the solution wasn't, but we also never made a precipitate either. There was no precipitate that was blue. There was no solution color which was blue. So I know that copper 2 wasn't in there. Okay, so we're continuing on with our lab here. We're just gonna keep answering some questions. So it says, what ion in the original sample solution was confirmed to be in the solution based on step 4? Now step 4 was our flame color, and our flame color produced was red, and this confirmed that we had lithium ion. Okay, now a follow-up question says, could the student precipitate out this ion instead of using a flame test? If so, give an example of a solution that could have been added to precipitate it out. Now, lithium is a group 1 ion, and normally almost every single group 1 ion is soluble with everything. This is like a one-time exception. So if you looked at your data book table, you would notice that it is insoluble with fluoride ion. Okay, fluoride ion is insoluble with lithium, a lot of the group 2 metals, and a couple of the transitions. So I could have added fluoride ion to make lithium fluoride solid. Okay. Number 6. Explain why it is important to add hydrochloric acid before adding the sulfuric acid. So let's review what we did. We added the HCl in order to remove out the lead 2 plus. Okay, that's what this step was for. This was to make lead 2 chloride solid. Now, if I added sulfuric acid first, which is H plus and SO4 2 minus, let's check out what sulfate is insoluble with. Okay, sulfate is again insoluble with calcium, strontium, barium, silver, mercury, lead 2 plus, and radium. Now, that's not going to work at all. If I added sulfate first instead of chloride, I would take out calcium, which it did, but it would also have taken out lead at the same time. So that wouldn't be a selective precipitation. That would be removing 2 ions at once, which we don't want to do. So it says, explain why it's important to add hydrochloric acid before the sulfuric. Because the sulfate ion will remove both ions at once. Okay, so because the sulfate ion would remove both the calcium 2 plus ion and Pb2 plus ion, and therefore we don't know which ion is coming out or if it's just 1 or 2. That's why we wouldn't do it first. Okay, so next we're working on our net ionic equations for a couple of the steps. So without having to scroll back, I can just kind of do a quick review here. In step 1, we just did this. We were looking at lead was being precipitated out with chloride. Okay. In step 2, we had calcium reacting with sulfate. In step 3 of the lab, we had cobalt 2 plus reacting with, let me just double check, a sulfide ion. Okay. All right, so now they want a net ionic equation. So we're just going to balance these. I'm going to do it in a different color so it doesn't conflict. So I would have Pb2 plus aqueous reacting with Cl minus aqueous, turning into, if I balance that out properly, PbCl2 solid. Now I do need to make sure this is balanced properly. So I've got one lead, and I have 1 Cl and 2 Cl. So I need a 2 there. And just to double check my balancing, I should check that the charge is balanced. So 1 times 2 plus is 2 plus. 2 times 1 negative is 2 negative. And then 1 times nothing is nothing. Okay, so 0 is equal to 0. On the next one, I have Ca2 plus reacting with sulfate 2 minus. Those charges balance out nicely, so this is CaSO4 solid. I got 1 calcium on the left, 1 calcium on the right, 1 sulfate on the left, 1 sulfate on the right. And if I do my charges, I got 2 plus here, I've got 2 minus there, and I got a total charge of 0 there. So 2 minus and 2 plus is equal to 0. And lastly, I've got CO2 plus aqueous reacting with, I'm going to do this in the proper color here, CO2 plus aqueous plus sulfide ions aqueous turns into cobalt sulfide solid. And again, I have a 1 cobalt on the left, 1 cobalt on the right, 1 sulfide on the left, 1 sulfide on the right. So this is 2 plus, this is 2 minus, this is equal to a total charge of 0. All the coefficients are 1. So that's the end of our lab quiz section on how we would analyze a qualitative analysis lab. It's too bad we weren't able to do one of these together. They're quite fun, but maybe in the future you'll have the chance. I hope you have enjoyed this lesson of You Got Hope Chemistry. See you next time.